Even though that's the first problem in LeetCode, but it can be a challenge, especially if you're new to LeetCode problems. So in this video, we're going to take a look at two different solutions for two sum. So without any further ado, let's just get into it. There we go. Let's just take a look at the description. So in this one, we're going to be given an array of some different numbers and an integer target. So simply, we're going to be given an array of some different numbers and a target, and all we need to do is return the position of the two numbers that add up to this target. And so let's just take a look at example 1. In this example, our target is 9 and we have like some numbers over here. So my question to you, is there any combination, like a combination of two numbers that add up to this target in this array? There is actually one combination, which is 2 and 7. If we just add 2 plus 7, that evaluates to 9, and that's perfectly fine. So we just found the combination. So what are we going to do? We need to return the position of 2 and 7 from this array. And if you're familiar with arrays, you already know that indices start at 0, 1 all the way to the end. So all we need to do here, we need to return the index of 2 and the index of 7 respectively, or just they told us that you can return the answer in any order, doesn't really matter. So what I'm going to do, I'm going to return 0 and 1, and that makes sense because if we add the number at the index 0, which is 2, plus the number at index 1, which is 7, that evaluates to 9, and 9 matched up with the target. And also they told us that the input would have exactly one solution. In other words, this array is always going to have one combination that matches up with the target. So you never have to consider the scenario of this array doesn't contain a combination or anything like that. And they told us that we're not allowed to use the same element twice, meaning that let's just imagine that our target was 6. You can't just use like 2 plus 2 plus 2. That's not allowed in this problem. But what you can do, you may just get 2 plus 4. Let's just assume that that's 4. You can just return the position of these numbers. So how do you even return the position or just the indices of the two numbers that matched up with the target? Let's just take a look at the first solution. So the first solution we'll look at is just by using a nested for loop. And the reason why for me using like two for loops here is that we need to make sure to implement 2 pointers. So that's going to be I is going to be over here, and j will explore the entire array, will explore the rest of the elements, and that's because we need to make sure to cover every single combination. So initially we're going to check 2 plus 7, and then 2 plus 11, and then 2 plus 50, and of course once we find like a matching combination, we're going to make an early return. And lucky for us, the first combination just works out. If we add 2 plus 7, that's going to be 9, and then we're going to compare that with the target, so they match up. So what are we going to do? Like, my question to you, how can we return the position of the two numbers that add up to the target? You can simply just return I and j. So in like the first iteration, I that's over here at 2, that has the value of 0, and j that points to 7, which occupies the index 1. So we're gonna end up with 0 and 1, and that's perfectly fine because if you remember, that's actually the correct answer for this example. But let's just imagine that this target was something like 70. In this case, like the first combination of 2 and 7 doesn't work. Let me just clean things up a little bit. In this case, the first combination doesn't work. So what are we going to do? We're going to move on to the next combination. That's going to be 2 plus 11, that's 30, and 30 doesn't match with 70. So let's just move on. Finally, we're going to find that 2 plus 50, that's 70. So we just found the combination that we were looking for. So what are we going to do? We're going to go ahead and immediately return I and j, and I here just has the index 0, so let's just return 0, and alongside with that we're going to return j, and I believe that's index 3. So if the target was 70, we would return 0 and 3, and that really makes sense. So let's just go ahead and implement the first solution, or just translate it to some code. So where do we start here? Remember, we just mentioned that we're going to be using a nested for loop. So let me just initialize I, that I pointer is going to be at 0, and as long as I less than nums.length, keep going. And I'm going to do something very similar with the j pointer. I'm going to say as long as j less than nums.length, go ahead and just keep moving j to the right. And here we need to make sure to cover the scenario of if we wouldn't want to make like, and the first thing we will cover is that we want to make sure that we're not going to be using the same element twice. How can we cover that? I'm going to cover that explicitly by just one if statement. I'm going to say if I equals j. Let's just imagine that we have this array 2 and 3, and like using the nested for loop, that means that the first iteration we have I pointing to 2 and also j pointing to 2 and 3, because we just initialized j at 0. So we want to make sure, right, if they equal, if I and j pointing to the exact same number, go ahead and just continue. We're going to ignore that situation because we wouldn't want to just take the same element twice. Otherwise, it's time to get the combination. So I'm going to say to sum. So my question to you, how can we compute the combination? It's all about just adding the number at the pointer I plus the number at pointer j, and then we're going to check, alright, once we find a valid combination, once to sum matched up with the target, go ahead and just make an early return. And of course we can just return I and j, they represent the position of the two numbers. And let's just go ahead and ensure that the solution works. So let me submit real quick, and there we go, that's working. But as you can see over here, that beats like 77%. In other words, that's not very efficient, and that really makes sense because using a nested for loop, that means that the time complexity is going to be, let's just say time complexity, that's n squared, because we're using like a nested for loop. In other words, in the worst case, we're going to check every single combination in the array, and that's actually not very efficient. So let's just go ahead and take a look at the second solution, or just the next solution, and that runs in just linear. We're going to take a look at a solution of linear time complexity, but also it comes at a cost of the space complexity. That's going to be linear time and space. So let's just go ahead and take a look at that one. So let's just take a look at the overflow of the linear solution. So the time complexity is going to be linear because we're going to be using just one for loop to scan through the array. And also we're going to be using extra space, and that's coming from the hash map. And if you're not familiar with the hash map, it's nothing more than a key value, just a collection of key value pairs, each key associated with a value. And I'm going to show you why a hash map works out in this problem. However, the trick behind this solution is just to come up with the remainder. The reason why for me using 2 for loops in the first place was that we wanted to get access to every single combination and to check this combination with the target. But can we do the exact same thing without using 2 for loops? We actually can by making some sort of a trick. So we're going to compute the remainder. The remainder is just coming from the target minus the current number. Right now I pointer pointing to 2, so that's going to be 7. We're going to make one condition. Alright, does 7 exist in the hash map? It doesn't exist because the hash map is just completely empty right now. So before we jump to the next iteration, we're going to store the current number, or just we're going to mark things as visited. I'm going to store this as the key, and the value is going to be the index, which is 0 right now, and I'm going to show you why that's going to come in handy. And after that, let's just move on. Excuse me guys. And after that, we're going to move on to number 7. So the remainder is going to be 9 minus 7, and that's 2. We're going to check, alright, does 2 exist in the hash map? It does exist, and it does exist. So what that tells us, it tells us that we have access to the current number, which is 7, and 2, which is the remainder, does exist in the hash map. That means that we just found the combination that matched up with the target. So what we want to do here, we want to return the position of these numbers. How can we even do this? So we can just get the position of 7 by the pointer I. So the pointer I right now is just 1. And how can we get access to the position of the remainder? Like that's probably, like, remember I just told you that storing the index with this remainder is going to come in handy. We can just take the value associated with this number from our hash map. So we're going to end up with something that looks like this, and that's perfectly fine, because if you remember, they told us you can return the result in any order. So 1, 0, or 0, 1, that doesn't really matter. And that's it. Let's just take a look at how we can implement all of that in some code. Let's just go ahead and implement in the next solution in some code. The first thing, we're going to use a hash map, and that's as simple as an object. And then we're going to be using one pointer to scan through the array I. As long as I less than the length, go ahead and just keep going. And instead of here, the first thing, let me just store the current number in a variable called the current. And after that, we're going to get the remainder. Let me just say remainder that's coming from the target minus, just say target minus the current number. So what are we going to do after that? We're going to make one if statement. We're going to check, alright, if this remainder exists in the hash. If that exists in our hash map, we're going to make an early return. So we're going to return the value associated with this remainder in our hash map, and alongside with that, go ahead and just return I. Otherwise, that means that this remainder doesn't exist in the hash map. So before we move on to the next iteration, we need to mark things as visited. So in order to mark things as visited, what I'll do, I'm going to check, alright, if the current number, let me just check the opposite. If the current number doesn't exist in the hash map, we can just check this by using the exclamation mark. If this current number doesn't exist in the hash map, go ahead and store it, hash at current, and the value is going to be just I, it's just the pointer, and that is it. We don't have to return anything after this for loop, because they told us that you're guaranteed that this array contains like a combination. So let's just go ahead and submit the session, see if that works or not. I hope that we get some accepted. There we go. That's accepted, and it beats like 95% of the of LeetCode solutions, which means that's pretty efficient. Congratulations, you just solved it to sum, and this solution beats 95% of LeetCode solutions. That's because we're just using one for loop, but it comes at the cost of the space complexity, but that's perfectly fine. However, let's just say the time complexity is going to be linear, and also the space is also linear. I feel like it's time to wrap things up. So if you enjoyed this video, make sure to leave a like, and if you don't want to miss the next video, make sure to subscribe, and peace out.